All right, I think we're live everywhere. Appreciate y'all joining again. And guess what? I'm doing another coding challenge tonight. Another easy problem from Leetcode.com. I'm not going to talk too much this time. Appreciate y'all joining. Hey, what's up, man? See a couple people join. Appreciate y'all joining. Somebody says depth first search. Yeah, we'll see. I don't know. We'll see what this looks like. Well, yeah, we're gonna try to tackle it. Oh yeah, creating a visit. Yes, looks like somebody's been doing some Leetcoding or some coding challenges or whatever. I think it's interesting that we call it like Leetcode. It just feels like a game, man. But I'm gonna jump right into this. The question I'm doing tonight is linked list cycle. So this problem has to do with linked list. Obviously, from the title, given the head of a linked list, or given head of a linked list, determine if the linked list has a cycle in it. There's a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, POS or position is used to denote the index of the node that's the tail's next pointer is connected to. Note that POS or position is not passed as a parameter. Return true if there's a cycle in the linked list, and otherwise return false. So they have a little example here. So it looks like there's 3, 2, 0, and 4, and then the linked list, you gotta know what a linked list is. I say look it up if you can. It's basically a list of nodes that are connected by some pointer. And that's how, it's like one directional. For this type of linked list is one directional, where one node points to another, points to another, points to another. And in this case, we're trying to detect if there's a loop where one node points back to a previous node, like a parent or grandfather or great-great-grandfather node, and then it's kind of like stuck in a loop at that point. And so for this one, 3, 2, 0, and -4, there is a loop because there's like position 1 where it says this position that they denote here at the top is basically saying that there's a loop, but really it's like, I think it's like part of the code to run the problem, but it's not actually part of the problem, which is weird. But yeah, that's what it is. So yeah, basically in this one there is a cycle because the tail connects to the first node, and this kind of tells you which node that it's connecting to. And then in this problem, in position 0, they're basically telling you there's a loop, but you won't have this passed in, so you won't know what this is. But this basically kind of tells the problem that there's some sort of loop there, or tells you that there's some sort of loop there when you're reading a problem example. So, but here obviously is a loop. You can kind of tell the loop from just looking at these. And then this one, of course, is just 1, so there's no loop. There's no pointers here at all. So, yeah, this is the problem. There's constraints here. So there could be 0 nodes. So that's an important edge case here to take into account. And then position is -1 or a valid index. So if position is -1, that means there's no loop. But position's like not even, when you look at our problem over here, it's not even getting passed in. So it's really not even part of our code. It's just something for this problem to kind of like denote for these examples. Like when you're running examples, you need something to denote that where the actual loop is. And hey, people, for joining on Instagram, YouTube, everywhere, Twitch, everywhere you are. What's up? I see some people I know in here, so what's up to y'all? Cool. So how do we solve this? So I solved this before, but as always, I can forget. And so y'all are going through this with me, like right now. I'm gonna like work through this with y'all. I'm gonna try to make sure I do some teaching, do some learning at the same time. So, okay, let's get started. So, like always, how I like to tackle my problems is kind of think of it in my head from just like how would I solve this on paper type of way before I take that and try to figure out what algorithm or data structure I could use to solve the problem. So solve it in my head first, figure out an approach, and then figure out how to take these common data structures and algorithms that I already know and apply them to the problem, to the solution that I came up with. So I'm looking at this. I mean, it feels like a simple project from a simple problem or solution from like just eyeballing it. So you're looking at a linked list. You can tell once you repeat a node again that you have a loop. If you don't repeat a node again, you don't have a loop. So what can I do to basically detect that I have that I've like going into a repeat of the same node? In my thinking, I just need to keep track of every node that I've seen. So what's the best way to keep track of nodes you've seen and be able to quickly and efficiently check the nodes that you've seen? The best way to do that is a map or a set. And so in this case, if all of these are unique, and the problem doesn't say that the values of the nodes are unique, but I think we can assume that from the sets that are in. If you were in an interview setting, you probably would need to ask that, like if all of these values are going to be unique. And so if I store all of these in a set, then I can basically say, as I iterate through the linked list, looking at every next node, I could say, have I seen this node before? If not, then keep going until I get to the end. And if so, then I have some kind of loop. If I've like seen 2 before, for this example, then I have some sort of loop and I can return true. So without further ado, I'm going to try to jump to the code, because this one, actually, I think this problem has multiple optimizations. I'm actually pretty sure that it does. I'm pretty sure I'm not doing it the most optimal way. But, and no, somebody asked if I'm going to use recursion. No. And yeah, this is an easy problem. But easy is relative. Like, I don't know. Like, some of these, like, they feel easy, but if you can't understand it, it can become hard quickly. But as you do more and more of these, they do get easier. So, anyway, the solution I just came up with was basically to loop through the linked list and then store everything that I've seen before, and then check as I go through, check if I've seen it before. If I have, then return. If not, then return false. Or sorry, true. If not, then return false after I break out of the linked list. So I know the first thing is I need, sorry, not a map, but I'm going to use a set. And I hope I'm doing this right, because it will suck if it doesn't work out, but we'll see. And then secondly, I think I need something to keep track of the node that I'm on. I guess you could kind of do this with head. And one more important thing I wanted to mention is that, like, here Leetcode is giving you a definition of what a node looks like. So head is actually, this is what it looks like. Head has a value, and then head has a next, which points to the next. That's what points to the next object in the list, the next node in the linked list. So that's an important thing to understand. Like, before you even try this problem, you need to go figure out, like, you need to go learn what a linked list is in your language. Like, that's just kind of like a prerequisite to doing this, to even trying this problem. So to start, like, my current node is just going to be head. And then I'm going to say, so let me think of like how I can loop through my linked list. So if the linked list, So how does a linked list end? A linked list ends when it has nothing else it's pointing to, or if it's going in a circle, it just gets stuck. So I need to stop if it's stuck. But if it's not stuck, then I can say while current node is not equal to null. Because if current node is equal to null, after I keep looping through, or not looping through, but after I keep iterating through my linked list, then that means I'm at the end of the linked list. And if I'm at the end of the linked list without finding a loop, then I need to return false, because it's not a loop. It's not any loop in this, or any cycle in this linked list if I get to the end and I haven't found any cycle. Because I should never get to the end of the linked list if I don't find any cycle. So, all right, so current node is not equal to null. And then what should I be doing inside of here? Let me make sure everybody can see what I'm doing. Yeah, everything's good. Okay, cool. So what should I be doing inside of here? So I think the first thing I want to do, like I said when I thought about the solution, is I should check my set to see, does my set have the current node? If it has the current node, like in this example, in this example, if I've passed 2 and I've went all the way to 4 and then I come back to 2 and it has it in there and I've put all of these in a set and I see 2 again, then I know I'm in a cycle. So this is my cycle check. Set has current node, then I know, hey, I'm in a cycle. Just return true, breakout, don't even do anything else. If not, then I need to put, and this is where you have to have command over your language for these type of problems. It would take me too long to explain every single piece of code that I'm doing, but like in your language, you want to have a command. You want to know what your data structures are. You want to be able to do a loop. You want to know how to use a set. Like that. These are things you should practice before you even start a problem like this, to kind of take a tangent for a second. But anyway, I need to add current node to my set. So as I'm going through this for 3, 2, 0, 4, I'm adding that to the set basically in this example. I don't know why the screen keeps doing that. Sorry. Yeah. So I'm adding these to my set. And then now I think I might be done actually. So let's think about this. I'm looking at this. I have a set. I have a current node, which starts with the head. And then I go through, if current node is not equal to null, it's not at the start. If it's in the set, I just go ahead and return true. If it's not in the set, I add it to the set. And then if I get out of this without ever finding something in the set already, then I just return false. So what I like to do is a quick example. We're going to use 320 and negative, what is that, negative 4? Yeah, 320 and negative 4. 320 and negative 4. So like in an interview setting, sometimes you won't, 320, negative 4. Sometimes you won't be able to actually run your code, and the interviewer is going to expect you to like do this manually. And what you can do is write these comments to like keep track of your variables. So like here, I'm going to say head is equal to this. And I'm also going to say like the loop is 2. So like that's why in the problem statement, they have that POS thing, because it has to be somewhere to tell you where the loop is. Otherwise you wouldn't know without drawing the whole thing. So I'm going to put like loop, the loop point is 2 in this question, in this example. And then I know I have a current, I have a set, and then I have a current node. And I think those are my variables. So what I do is just put a comment for every variable, and I'm going to walk through this with this problem, this example, and see if I get the right answer. So like result, is it true or false? So let's do it. Head right now is 3. Here's my set, current node is 3. is current node not equal to null? Yes, because it's 3. Does the set have the current node? No, the set is empty. So I skip that. Add this to the set. So I'm going to add 3 to the set. And so then I'm going to go back up to the top of my loop. Is current node. And you know what I see? This is when you do this. This is why you do this, because you find bugs. What I found as a bug is that current node, I don't change current node. Current node is just stuck at 3. So the part I missed is current node needs to be updated to current node dot next. Because remember, in our thing up here, the way it's built, variable next points to the next item in the pointer. That's where your pointer is going to the next node. Yep, so this is why you run through your code in your head before you even run it, because you can find these issues without being like, oh dang, I ran it and it messed up. So current node is equal to next. So now my current node is 2. I come back to the top of here. It's 2 not, equal to null, of course. Does the set have 2 in it? No, the set just has 3 in it. So add 2 to the set on this line here, and then update the current node to the next, which is 0. And then I'm going to come back again through here, and I'm going to go quicker through this part. We already know what's going to happen. We're going to add 0 to the set. We're going to change 4 to the current node, and then we're going to end up adding 4 to the set again. And this is the interesting part. Where is 4.2? We said our loop is 2, so 4 is pointing back to 2. So now my current node will go back to 2, because the loop is going to go back to 2. So then I'm going to come back here. Is current node equal to null? No, it's not. Does the set have current node? 2. The set does have it. Return true. Our result is true. What was the answer to the problem? Dang, I keep messing that up. What was the answer to the problem? It's true. So we're correct for this problem. And yeah. So what I usually would do in this case, if I wasn't on a video and trying to save some time, is I would run through a negative case too, where it equals false. But I'm not going to do that for the sake of time, because I do want to try to do an optimization to this problem that I can see. Or I've done this problem before, I'm not even going to lie. So I know that there's an optimization that I can make. Hopefully I can remember how to do it correctly, but we'll see. So the next step, when you're on Leetcode, if you run through this, somebody missed the first couple of minutes, I'm going to post this again on my channel right after this. And thanks everybody for joining. So I'm gonna run through this. If you're on Leetcode, or if you're in an interview, or you're doing this on your own and you have a runner, then of course you want to run it against all the test cases you can think of, or you want to just run through it, like I did here for an interview or something like that. But we have Leetcode, so I'm gonna run it. And I got the right answer for this answer set. And so instead of running it manually to save some time, I'm actually going to use the code runner. So this is the second case. Actually, I'm going to try this third case that's negative. I'm going to put 1 and -1, and I should get false. So Leetcode allows you to update your test case to anything you want. I should get false here. Yep, I get false. So now I'm going to submit it to Leetcode and see if I get the right answer. Okay, yeah, so I got the right answer here. It wasn't that good as far as against the other people. I only did it faster than 17% and used less memory than only 9%. But I want to try an optimization here. Let's see. So I think the problem said something about an optimization. Yeah, it says, can you solve it using only constant time, big O of 1, or constant memory, I'm sorry, not time. Can you solve it using constant memory? And so what they're talking about is, and I didn't do the big O analysis. That was something that I should have done. In this case, since I'm using this set, potentially for every item in the list, I'm going to add it to this set. And so, unless I find a loop earlier somehow, but worst case, that's what big O runs off of, is worst case, or that's what it's set off of. And so this, I would be using O of n, if n is the number of items in my list, memory, to just do this problem. And then as far as like time complexity, I'm going through every node once, worst case. And so I'm using big O of n, or linear time complexity. So the memory or the space complexity is big O of n, and the time complexity is also big O of n, because if n equals the number of linked items, then I'm looping through n times. And so that that's the space and time complexity. So what they're saying is like, can you do it without basically using like constant memory, which would mean I couldn't use a set. I could only use like variables and like things that are like not bound to my input. So like setting a node, or doing these like incremental like doing these one-off operations aren't bound to my input, so they're constant time operations. So what I think I can do here is what's called I'm going to erase all this too, what's called I don't know what to call it. I think it has an official name, but what I usually call it is like a tortoise in the hare pointer solution. So like, how can we do this without having to store something? And this is a trick that I've learned, and a lot of times with these interview problems, it's about learning these common approaches to solving them and learning when to apply them, because there's so many problems on Leetcode. Just trying to memorize them all doesn't work. You're gonna memorize some of them just out of human nature, but once you do memorize them, you can use them for tougher problems that you wouldn't be able to memorize, because okay, I solved this problem with this thing, so I know that if it's a similar problem somewhere else, then I can solve it with the same method most likely. And so there was another problem where it was like find a cycle in an array or something like that. So even in a linked list, finding a cycle, I can use like a similar approach. And what that approach is can I pull this down? Yeah. Is having a slow and a fast pointer, or like iteration through the list itself. And so what we would do in this solution, basically, dang, where am I? Oh, here, sorry. Is we would have a fast, like just like the last time I went through one by one, I could have one iterator that's going through one by one, and then I can have another iterator that's going through two at 2 by 2, I guess is the term, but it's going to skip one every time it goes. And what you can figure out from that is that if there's a loop, because eventually these pointers are going to equal each other, because you're going with the second fast pointer 2 times faster than the first one. So if there's a loop, eventually the first one's gonna like think about if somebody's in a race and they're going twice as fast as somebody else, eventually they're gonna like catch up to each other in the same spot, because if by the time one racer finishes one lap, the first racer just finished his first lap, but they both finished they get to that lap at the same time if they're actually running exactly double the speed. And this is what this is. If I'm moving the pointer 1 speed and I'm moving the other pointer exactly 2 times as fast. So I explained the solution, and that goes a long way, especially in an interview format, and even not in an interview, just kind of at least having an approach for what you're going to do. But now it's time to see if I can remember how to do this, because I'm thinking about this in my head while I'm talking to y'all, trying to remember how to do it. And so if I don't, I'm just gonna look at the answer, because hey, we're just learning here and this is what it is. But I do know for a fact that with the fast and slow, I know that I want to look at the first, and I want this one to I want this one to increment 1, and I want this in increment 2. So what I can do is just start the pointers off at head and head next. But their head could be empty, because I think in the problem thing it said, yeah, it could be the number of nodes could be 0. So there could be no node. That could be null. So I think I need to check. And maybe I should have just left that there just as a teaching moment if like I missed it. But I don't know. I just thought of it, so I should just put it in there. So if head is null, then there's no cycle. So I'm going to return false, because head could be null. But then next I'm going to like set this to slow and fast. I'm going to say wow. Okay, so when I was doing the problem, I was explaining the problem, slow and fast, if they catch up to each other, the fast one catches up to the slow one at any point, then there should be a loop. So if slow, I'm gonna think, should I do value or just should do I think if slow, while slow does not equal fast, then I want to go, yeah, while slow does not equal fast. And so if slow ends up equaling fast, I'll break out of this loop. And in that case, I want to return true, because if slow equals fast, that means slow's basically like lapped. Because if it's just a linked list without a cycle, fast will outpace slow so much that it'll never be the same. But if it does somehow equal it, I'll break out this loop. But then won't that mean I'll get stuck in an infinite loop here? Well, yes, until I write some code to break out of the loop. So here I'm going to basically write some code to get out of the loop if either, thinking if either slow equals null or... And slow can't equal null at this point. So it might be, I'm trying to think, is if slow equals null or fast next equals null. It might be something like that. Or slow next equals null or fast next equals null. Yeah, I think that's what it should be. Slow equals null or fast. So basically, if I don't have anywhere else to go after this, I'm at the end of my loop, then I need to basically break out and say this is not a cycle, because a cycle, you'll never get to the end. And so I should break out here because I don't want to get stuck in an infinite loop. So if either of these is null, then I know I'm at the end of the cycle, which fast next I think is going to hit it the quickest, which maybe I only need fast next here. I'm gonna try that, and then if it doesn't work, then whatever. Or maybe I just need fast. If fast equals null, yeah, like that. Because if fast equals null itself or fast next, then I need to break out. And then here, I need to say, I need to iterate slow. So I need to basically make slow equal to slow.next. And then remember what I said about fast being twice as fast as slow. I need to go to next. I need to jump 2 for that one. And so I know, right, so I know next has something in it because I've checked it here. So I shouldn't have any kind of issue here. And so, yeah, so this is the answer. I think I'm probably going to just go through this one mentally. I'm going to run it. I'm not going to go through the long process I went before because I don't want this video to be like super long with these multiple parts. But Yeah, so head equals null, return false. So if I have nothing in head, then it'll return false. And then slow, I'm going to set it equal to head. Fast, I'm going to set it equal to head next, because I'm trying to jump 2 every time for that one. So from 0 to 0, 0, 1 or 1, 2. And then while slow does not equal fast, if slow ever equals fast, then I need to return true, because yes, I have a loop. Like slow has lapped, fast has lapped slow, and it equals it because it's lapping it at exactly 2 times the speed. If I get in here and fast equals to null or fast next equals to null, then I need to return false, because I've now reached the end of this linked list and I can't go farther if I wanted to. And if I've reached the end of the linked list, there's no loop, because the end of the list should loop to something else. So then here, if I'm not at the end of the linked list, I need to keep moving forward. Slow moves 1 and fast moves 2. Double the speed of slow. So that looks right to me. I'm going to run it and we're going to see what happens. Okay, cool. So our first test case is right. Let's go and try another test case. Let's try this one's more complicated. This, and then position the loop is 1. So this one I just tried has no loop. This one has a loop at index 1. So I should get true for this one. Yep, got true. And I'm going to try one more. This one should have a loop at index 0, as you can see in the picture. Okay, got it true. So now I'm going to submit it to Leetcode and see what happens. And thanks for joining, people. Appreciate the support and hope you're learning something like I am. I'm learning something while I'm doing this. So yeah, that was successful. And if you see, like last time I got like 17% that it was faster than, and then even for the memory usage, I was like low too. So now I'm at least, my memory is at least less than 70% of everybody else's submissions. And it's faster than 50% of everybody else's submissions. When last time I was like at the 17 range for both of these. So this was definitely an optimization. This time I'm not using any extra memory. It's constant memory, and it's big O of n time, because for every head I at least need to loop through it I need to look at it at least once. Even though I'm looking at it with 2 pointers, I'm still only going through it with n operations if the length of the list equals n. And then I'm not having a set or a map anymore, so I'm not storing anything in memory. As soon as I pass these lines, I'm just putting these directly in memory. But this is constant time. These are not tied to the, like, no matter how big this is, the number of times I set these doesn't change. So this is considered constant time and memory. So it's not bound to the input. So I hope you liked that. It was a little longer one. I wanted to try one that had an optimization in it, since last time I had a really good discussion on there about like, hey, I think you can optimize this, and I didn't for the sake of time, and I really didn't know how to optimize it. I didn't really know there was an optimization. So thank you to that guy who mentioned that in that previous problem. But hope y'all like this problem. Please let me know if there's any particular problems you want to do. Whatever platform you're watching me on, thank you. I really appreciate you guys watching these, and I hope you're learning something. And, follow, share, subscribe to the video when I post it. Subscribe to the channel or whatever platform you're on, and share the video when I post it. And I appreciate you guys. Have a good night. Thanks.